Welcome back, viewers. MACTFORDEDGE here. And why should I watch what my coolant level is, and how can low coolant destroy my engine? We all think overheating, but I'm going to make a point about the water pump and how low coolant will tell you whether or not your engine may blow up.
Welcome back to a MACT video. Car repair is fun.
Now, there are a lot of reasons why you could blow up your 3.5 Duratec, and I'm speaking mostly to this and the internal water pump. Now, there are a lot of engines out there that run off the serpentine belt and have the water pump really exterior to the engine. Case in point, I had a leaking water pump on a Suzuki that I owned way back when, and it was internal. It was an expensive fix, folks. Just to replace it, it cost me $1,600 because I paid somebody else to do it way back when. Pretty much that's what you're looking at here at this 3.5 Duratec. I will explain it here later on in this video and have some photographs of it and everything else as far as how it looks on the inside and everything else. So we'll follow along on that. But first I want to explain a few things about our water pumps and how you can determine or may not know until it's too late that you have a water pump failure. Now, the water pump, as we're going through everything, is mounted as you're looking at the engine on the passenger side, left side. Of course, that is the front of the engine. Basically, it's underneath the motor mount. Okay, so you have to remove that along with some other things, coolant tubes and other stuff to get access to it. And then you got to remove the actual cover off of the timing chains. Now, the reason I'm going down into this is because everything follows a path, folks. And coolant will always seek the lowest point of gravity. So follow me with this. Your coolant, of course, is going to be up here. And let me show you. Now we have our coolant bottle. We keep track of the coolant level. Very important in the first place. Because if your coolant is disappearing, the thing you have to ask yourself is, well, it's a sealed system. Where did it go? I have no coolant on the ground. Where did my coolant go? So, there's only really one route then after that your coolant can go. Now, down up the front, down here, okay, is your valve cover, not valve cover, is your cover for your timing chain and everything that runs, of course, your VCTs and everything else. Now, down up underneath there, you have to take that off. So you get down in there and you'll see down here is your belts and everything else. That is where it's hidden back underneath there. Now, what happens is, and I'll explain it further with photographs and everything, but in a nutshell, what happens is it's a closed system, okay? The water pump is internal to the engine. In other words, it is behind the cover of the timing chains and everything else. Those timing chains are lubricated by oil. Down below at the bottom of the cover is the oil sump. Since your oil is very open to the timing chains to lubricate, should that shaft or any of the seals have a failure, the water or coolant in your system has to go someplace. What it does is it then makes its way out of the housing for the water pump. Well, when it makes its way out, since it is behind that cover, it mixes with the oil. It then goes down into the sump of your engine and mixes with your oil. And you can tell that it's mixed in there because when you do check your oil, if it comes out looking like it's chocolate milk, you now have coolant mixed with your oil. Therefore, you should not run your engine any further. to that point, there's a lot of damage that can occur if you continue running it, because engines do not lubricate when they have water like coolant in them, because there's no more friction reducing material there as the oil will provide. So the water is not very good for that. So it will cause all sorts of problems with your engine oil, and ultimately cause bearings to go, and of course ultimately blow up the engine. Now I hope everybody can follow along what we have here. It's starting to rain, so I'm going to try to get this done. But we have our water pump that's leaking. It's leaking water. It's getting down into the oil pan. Now it's not much. Say we just lose just a little bit and we fill it back up. Right over here we just lose a little. Okay, while the engine is running, the engine creates heat. It's running about on the average 196, 198 degrees at the cylinder head and temperature sensor, so it's running almost 200 degrees. You add water to the oil, the water is really going to start to try to evaporate because it's really next to its boiling point. So it will then go up through the engine and go into your PCV valve, out through your breathers right here. Okay? It'll go out through the breather, and if you follow it, where does it go? It goes into your intake. Same for the PCV. It feeds into your intake. Now, what you're doing is you're evaporating the water out of the oil, and therefore it's going into your intake, being ingested into the intake, combustion, and then being out through the exhaust. Okay? So I hope that answers why you might not see that water, because technically it's a closed system and it's getting into that closed system because now it's being fed and digested by your engine and then sent out the tailpipe while it is running. So that would probably explain why you might not see an oil level increase, because the water is being boiled off and ran in through the intake and then out the exhaust. So this is only a case when there's a small leak. If it's a big leak, it's going to start filling up your oil pan and of course making your engine run bad. If it's just a small one, you might not notice it, folks, other than the fact that your coolant level is dropping. So that is why you must pay attention and maintain it. But hopefully that explains some of the idiosyncrasies of what's going on with that engine, and you can understand that better. But it is now starting to rain, and so I'm going to go ahead and wrap this up and get the computer part of it done, and we can go over those issues. While we look at this picture of the engine, we're going to see that, of course, on the 3.5 Duratec, we do have, of course, the exhaust cam and the intake cam. And to take special note of the engine as far as it's set up, and we're going to explain that more into where the water pump is located in accordance with how the engine is actually set up, which is very important. Now, one thing that you will notice as you are taking and going through the engine, you take the valve covers off, or even check the oil with the dipstick. You want to look for the oil. It may be a milky colored or brown colored oil. Basically that's a mixture of water, air, and coolant with the oil, and that's what happens when it froths up and gets really mixed in. It will of course eventually separate if it sets long enough, but if it has been running, it's going to of course look this milky color, and then that is what your contaminated oil will look like. Now, as you can see, we have the cams, and you have that intake chain, and then you have the exhaust cam chain. Now keep in mind that the main chain drives the exhaust cam chains. Now it goes the full length of the front of the engine all the way down and through, and it also then has another chain attached to it that does drive the intake cams. So the main chain drives the exhaust, and the exhaust of course then in turn will drive the intake cams to help the engine function. And this is where of course we're going to have our loose chain when the water pump of course shaft fails or has play in it, then we will start having problems. Now as you can see, the water pump does have the cog on it also, and it is mounted pretty much upper center of the engine, and you will see that the main chain goes down around the actual crankshaft, and then it goes up over the exhaust shaft, and then back underneath the water pump, then back over the other exhaust cam shaft. So it does a big loop, and it sort of looks like the letter Y in a lot of ways. So when it's set up and the chain is set up. Now you can stand to reason that this water pump is actually more of a function of not only water as far as pumping your coolant, but it also functions as more or less an idler pulley. And of course, if it develops play, it affects everything else in the process. So when this idler pulley does stop working, then of course you're going to start getting that P0016 because it affects everything else. You start getting the slack and the slapping, and then eventually the timing is basically destroyed and the engine is not running good. Now directly below that water pump, you can see that spacing with the arrow pointed to it. Now that spacing down there is the oil sump or oil pan. So if you look at the picture, directly above it is the water pump. Well, it stands to reason if around the seals where the face meets up to the block, if those seals fail or that shaft on that water pump fails, where does the water go? Because there's a cover over top of this water pump and over the timing chains and everything else, so it's sealed. So the water can't literally leave the engine. It goes the natural route of gravity. It goes down into the oil sump, and then it mixes with the water as it's agitated. It then redistributes throughout the engine, and then that's when you're going to start getting your heating issues. Why? Because we all know water is not a lubricant. It has a lot of minerals and everything else in it, and it causes friction, and friction creates heat. And once we get the heat going, then we're going to start getting damage to engine components, and that is why you end up with a destroyed engine. Now in the diagram here, as you get from Ford, you can see that it comes in essentially two gaskets, then the housing, and then of course the cog and shaft. That's basically a diagram of what you're going to get when you do buy one. And as a rule, the gaskets are already inserted into the housing, and the cog is press fitted in already, so it's sold as an assembly. Now this is just a picture of the water pump, and with the timing chain side you see the cog and then see the housing, and you have 1, 2, 3, 4, 5, 6, 7, 8 bolt locations on the face of it, and they all of course have to be properly torqued so that you have a good seal in a certain pattern. And then this of course is a view of the back side, the face that goes against the engine block. So you can see that you do have your gaskets and everything that are already preset, and then the vanes for the pump itself. It is a pressed in fit, and it does have of course ridges on the shaft to help it keep from spinning, which I've had happen to me on another water pump before. So it's a good design feature there, but again, it's still an internal water pump, and it can create some issues. So you want to make sure that you do, by all means, give that a good twist and nice and hard to make sure it's good before you install it. Lesson learned from experience, I can tell you that much. So never take it at face value. Give it a good hard twist before you install it to make sure there's no movement. Because I had one, put it in, and boom, 100 miles later it spun right off the shaft. So you want to make sure you do a good test. But that is it as far as what you're looking at with the the diagrams of the engine and everything else and how it's set up. And of course now we can see the correlation between everything in that P0016 code, the water pump, and we all know now that when this happens, coolant's disappearing and everything else gets put together in an investigatory manner, we start deducting a water pump failure. And folks, that is how it works. Well, as you saw in not only the earliest part of the video, but on the computer, the photographs, and everything else I was explaining, the breakdown of the engine, the oil and the coolant, not good friends, okay? This is, you know, some types of failures that you're going to run across, and unfortunately, you may not have a whole lot of notice except for a couple signs. Your coolant is going and you have no idea where it went. No leaks on the ground, anything like that. The other thing is, engine is starting to get warm. And of course, your oil is starting to turn a chocolatey color. Not a good color. That indicates water. So what you need to do is pay attention. Check your engine once in a while. I'm not saying that this is a real common failure, but when this failure occurs, it can be devastating not only to the vehicle and the engine, but also to your pocketbook. I have heard quotes for a water pump change only, and keep in mind you're not addressing the bearings and everything else that may have been damaged, for like $2,000 at dealerships. Engine changes, $6,000, $8,000, folks, all because of a water pump. Now, the water pump failure alone is also very expensive to fix if you catch it early, but it's cheaper than an engine change. So you got to weigh what you got. Extended service plans may be of benefit. I personally don't do extended service plans, just never had luck with them. So, you know, some people swear by them. I don't. I fix my stuff myself as much as possible. But as far as working on your car, you know, check it, maintain it, be proactive, not reactive to your maintenance, and therefore your engine will last longer. I've never had an engine coolant pump break on a Ford Edge. I've got, they bottomed out their car. Anyway, I've never had an engine coolant pump, water pump failure on my 2008, nor on this 2011 or my other 2011. All over 530,000 miles at least on all the engines. So is it common? I'm not seeing that it's common, but it does occur. And it occurs to all engines, folks. It depends on the situations they're in. So you want to make sure that you do check your coolant. Make sure your coolant level does not have the disappearing act, and then that will be a prime signal that you do have a problem. Now, some of the things that you're going to also have to pay attention to, other than the lower fluid and of course overheating, and your engine oil is a little milky, chocolatey looking, is your you might get an engine code, and that is a P0016, which, believe it or not, has nothing to do with the actual water pump, but what it is a crankshaft camshaft correlation position situation. Now, why would I get a P0016? Well, it's really simple, folks. There is a lot to do with water and oil. Now, we know water and oil don't mix well, and in this case, antifreeze and of course oil or coolant, as we want to say. So we have to really stop and think, how is this all happening that I get this crankshaft camshaft CEL? Okay, the engine's overheating, got low fluid, got milky oil. What could be the central part of this to cause all this to happen? Now, I also want to tell you that the reason this is happening is we all know that water and oil don't mix. Said that already, and I'll say it again. Now, here's the thing. What does oil compress at? What does water compress at? Oil has a shear ability. It has a hydrostatic shocking reduction. Okay, what it does is when you have oil or fluid that is being shocked, in other words, run through the engine and everything else in operation, in that it affects your timing. Your camshaft position sensors and everything else are affected by the fact that they no longer have oil to register this marking, but now they're utilizing water. Water it can cavitate, it can cause air bubbles, and it also has a very fast and rapid response rate compared to oil. Oil is rather slow in what it does. Water is very fast and shocking, and this can cause some slop in there in that aspect too. But also the water pump shaft, it could be the #1 reason. The water pump shaft could be getting play, getting loose. The bushings on it that are going into the water pump itself are starting to get play. You will see that if it wobbles and moves, it will give play to the chain as it's going around. Now, with that play, that means it affects everything else because the chain is ran off of the exhaust cam, okay? The exhaust cam in turn runs the intake cams through another chain, but it's all interrelated, and the water pump itself serves as like an idler pulley, okay? So if there's play in that, that puts a lot of slack in the whole system, and then of course that gives you your sensors wrong. And on top of it, the tensioners that run the chains, they will be reduced value because they're not using oil anymore, but they are using water to actually push the tension, which is also causing another leak down effect on the whole works. So one problem can lead to a whole bunch of other issues that ultimately affect the timing of the vehicle and throwing the code. I don't want to get into the weeds on it too deep as far as all that goes, but just rest assured, if you're getting that code, your water's going down, your oil's milky and brown, guess what? It's your water pump, okay? So you want to make sure that you do relate that all to your diagnosis as far as what's going on. Now, got all that neighborly stuff out of the way. But we're back, and anyway, picking up where we left off. Now, if you run across an issue where you do have to take and say you had a catastrophic event with your water pump killing your engine, there are a lot of alternatives, folks. If you go to the dealer, you can buy a Ford recertified engine. Basically, it's almost a new engine. They'll go through and tear old 3.5 apart, and they'll take and rebuild the entire engine with all new components as required, and you get a good warranty out of it and everything else, but you will pay some bucks, okay? So if you're on the budget side of the house, the next step is to then buy a used engine and have the dealership install it, which will cost you a fair penny on top of that, anywhere from $5,000 on up, I could imagine. I haven't really checked the price, but I heard a lot of quotes online from various people that have had this issue. Not that it happens a lot, but it does happen. So, you know, $5,000 on up, a little bit of a hit on the piggy bank there. So here's another option, folks. There are a lot of vendors that sell used 3.5s out of other Edges that have been damaged and totaled, but yet the engine is still good. Generally, you'll get some sort of warranty on the engine for a certain period of time, but it doesn't cover the labor. If they put it in and turn it on and it don't start, you're stuck with the labor again to pull it out and put another engine in. So there's the pluses and minuses there. But you can use reputable companies, tough tongue twister today, to try to help you discern what is a good engine or not. And basically you can take and have a outside garage of your choice that you trust that says they can do the job and do the engine swap for you. And you would probably be better off at that route for budget and also for getting your Edge back on the road. So there's a lot of options to replace the engines once it does fail, should it ever happen. And quite frankly, if I had that event with me, I would choose my third choice and have an independent shop, along with I would probably do it myself just to save the money. But the thing is, it's not a real difficult thing. It takes time though. You're doing an engine swap, you might as well set aside a weekend or two to do it if you're doing it yourself. You also have to make sure that you have the right type of engine, folks. This is an IVCT engine, so you want to make sure you have the right type of engine for the right model year. You don't have to worry about whether it's manual or automatic. They're all automatic. But you do want to make sure that if you have a 2007 through 2010 engine, you put the same engine in it, because the other 2011 through 14 engines will not work in the first generation. The 1.5 refresh has a different variable valve timing system on it that won't communicate with your PCM. Therefore, it'll be a total failure for you. So you want to make sure that you do get the right type of engine to replace it. But again, that water pump, it can be deadly to a Ford Edge because it is internal, and when that water goes down into that sump, then all your lubricating capabilities for the engine will cease. It will create heat because of friction, and it will then start boiling over. One, it's probably ran out of fluid, the oil is not taken and lubricating, and then of course you have the demise of the engine, and then you're stuck alongside the road. So that is it on the water pump failure and how the whole system will react to it failing and how it can cause some catastrophic damage. So I really hope none of you get to experience this, but it does happen. I'm not going to say it don't, but it happens to all cars, okay? It doesn't matter. A water pump failure is catastrophic to an engine because it has to have that movement of fluid in order to cool it down. And when it stops, it will destroy it no matter what if you don't pay attention. So always perform your maintenance. Check your engine, check your coolant. Be curious. Why did I have to add a quart of fluid? Where did it go? So good questions to ask yourself. Checking that oil and doing regular maintenance will help provide you with the information to make good decisions on your maintenance and repairs. That being said, this is MACT Ford Edge, and by all means, I want you to go over here and of course join up on that Facebook page, and of course meet me, talk to me, and also talk to the other admins and get those Ford Edge questions answered for your MKX and everything. We even delve into the Fusion area a little bit, so just play with us there, and of course you can learn as you go, because we always like to help. The other thing is YouTube and Google+. Make sure you go over there, sign up, and of course join and subscribe to MACT Ford Edge on YT, and of course get to see the videos and get notified when I do put new videos out. But folks, every day's a great day, and when both feet hit the floor, I'm having a great day, and I want you to have a great day too. And with that being said, Mercy Girl has a couple of one-liners she's going to toss at you.
Thank you for watching MACT's videos, and remember to like and subscribe. This is a Mercy Girl production.
Hey, video.